Alright, today we're going to look at the unit circle and some stuff about the unit circle that you need to know. Alright, so when we refer to the unit circle, it's called unit singular because it is a circle with radius length of 1, just like singular. And within the unit circle, we have some trig values that come up a lot. So we've got sine, cosine, and tangent. So those are the three main trig functions you would see if you looked at it on a calculator. So now trigonometry is the study of triangles, so we often have right triangles. So where the circle comes into play here is, imagine this is the radius of a circle. So I'm not very good at drawing, but imagine this is the center and that there's the radius. Well, to get to that, here's an x-axis and a y-axis. You've got to go to the right sum and up sum. So normally we would call that a point, xy. And I'm going to call this length r. So yes, it's also the hypotenuse, but it's also the radius of the triangle. So back in your geometry days, you learned a helpful acronym that's still going to be very useful to us in this. And it says if you want to know sine, you compare up the opposite length over the hypotenuse. If you want to know the cosine of an angle, you can do adjacent over hypotenuse. And tangent, you compare up the opposite length over the adjacent length. So as long as you have a right triangle, SOHCAHTOA works out fine for you. Well, in this case, so I've got some distance x, some distance y, and some length r. So in this case, the theta that we will refer to is this theta right here near the origin. You wouldn't use this angle. You always use this angle here by the origin. So my opposite to my hypotenuse is y over r. So you can think of it as opposite over hypotenuse, but when we think of it as x, y, and r, it would be y over r. So cosine is adjacent over hypotenuse, and adjacent is x, hypotenuse is r, and tangent, opposite over adjacent, would be y over x. Now, as soon as you generalize, or that would be a general length r, but now let's say, well, what if r is 1, the unit circle? Well, if r is 1, this isn't just y over r, we can just think of it as y over 1. And instead of x over r, we can think of it as x over 1. So when we work with the unit circle, we're often going to memorize a lot of the points around it. And because of this reason, the x values on the unit circle will give you the cosine of that angle, and the y values will give you the sine of that angle. So that's the reason why it works out that way. Now, if sine is y and cosine is x, let's piece those down to this here. Tangent, we don't really memorize the tangent values on the unit circle, or at least not when we write the points. But y over r is like sine over cosine. So anytime you want to know the tangent of an angle, you can find its sine and its cosine, and you can divide those. And this guy here is called the quotient identity. Very important. We're going to use that many months now. Okay, so before I just tell you what the unit circle is, I want to give you some kind of background to it so that you can, because you do need to have it memorized, but you don't want to just like brute force memorize it, because you will forget it. So trying to compare the lengths and make a conceptual understanding of what's going on, I think, is the way to go. Okay, so there's five lengths that come up a lot in the unit circle. 0, which is of course 0, 1, which is of course 1, and then the other three that we're not as familiar with. 1/2 written as a decimal is 0.5. Square root of 3 over 2 is 0.866, approximately. And the square root of 2 over 2 is about 0.707. So I'm trying to highlight the decimals for you so that you can see the biggest of these three, because obviously 1's the biggest and 0's the smallest. But of these three, the biggest length, the one with the biggest decimal, would be square root of 3 over 2. The next biggest, the one in the middle, would be square root of 2 over 2. And the one with the smallest decimal is 1/2. Okay, so I'm going to come back to this. Knowing how those compare to each other, you can figure out a point, whether it's 1/2 square root of 3 over 2 or square root of 2 over 2, just by knowing those decimals. All right, and at least once for the year, I'd like you to know where those numbers come from. So it's not like a mathematician decided square root of 3 over 2 was his favorite number, so let's make students do a lot of stuff with that. It just occurs naturally when you're talking about 30, 60, 90 triangles and 45, 45, 90 triangles, the two special right triangles. Now, I have heard in recent years that this is common on the ACT, so you probably want to pay extra attention here for a few minutes for those ACT questions. All right, so this looks like a 30, 60, 90 triangle, and this is the 45, 45, 90. All right, so in a geometry course, you may not remember, but you memorized some ratios for these. So the ratios said in a special right triangle, if the smallest length is 1, the biggest length is 2. So the smallest length would be opposite the smallest angle. The biggest side would be opposite the biggest angle. And the medium-sized side would be the smallest side times the square root of 3. So 1 square root of 3. Okay, and then in 45, 45, 90, these would be equal. And the biggest side will be the smallest side times the square root of 2. So 1 square root of 2. All right, so that should sound familiar. Now, what this has to do with the unit circle is, remember this hypotenuse is like the radius of a circle. Okay, this is the radius of a circle. And we like to work with the unit circle if at all possible. It's just an easy, scalable thing to work with. So I can change this to radius 1 by dividing this in half. And these are proportional, so that's okay as long as I divide those by a half also. So you can start to see where the number 1/2 naturally starts to occur and where the number square root of 3 over 2 starts to naturally occur. So same thing over here. I could change this to a radius of 1, a hypotenuse of 1, by dividing by the square root of 2. And that's okay as long as I divide those by the square root of 2 also. Now that doesn't look familiar because we like to rationalize denominators. A lot of mathematics considers something unsimplified if you leave the square root in the denominator. So simple fix, multiply the top and the bottom by the square root of 2, and simplify, and then you can see where the square root of 2 over 2 naturally occurs. Now this is the exact same thing, so I'm going to cheat and skip those steps. I know it's going to come out to be that. So again, it's not like 1/2 square root of 2 over 2 and square root of 3 over 2 are just things that math teachers like. They naturally occur from these special right triangles that you've seen in the past, but fix them so they have a hypotenuse of 1, or in our case, a radius of 1. All right, so using the calculator a little bit, we've got 3 main trig functions. So we've got the sine, cosine, and tangent. And most calculators that can do sine, cosine, and tangent generally give you a dedicated button for those. So if you'd like to know the sine of 29 degrees, you probably should hit mode in the top left. Make sure you're in degrees, because 29 degrees is degrees. And then hit sine 29, enter. And that's about that, to the nearest thousandths. If you want to know the sine of a radian, hit the mode button. Third option down changes to radians, and then type in sine of pi over 9 to get about 0.4342. So you may want to pause the video there and type those in, make sure that you get the same things. Okay, So just because we've got those three main trig functions, we actually have three other functions, and they're called the reciprocal functions. We have cosecant, secant, and cotangent. So cosecant's the reciprocal of sine, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. And so what that means is, the reciprocal, remember, just like you're flipping the fraction. So you often will be asked, what's the cosecant of 35? And while your calculator doesn't have a cosecant button, you can say, well, cosecant is the reciprocal of sine, and by doing 1 over that, it gives me reciprocal. Well, by flipping it over, now I've got the reciprocal. So you do have to know that cosecant is reciprocal to sine. So in my calculator, I'm typing in 1 over the sine of 35 degrees. Change my mode back. And that's approximately that. Okay, so for cotangent, knowing that cotangent is reciprocal of tangent means you can just do 1 over tangent of that angle. And so this is what you're going to want to throw in the calculator. But now my angle is a radian, so I'm going back and forth quite a bit with the modes. And if you would type that in too, and be sure that you're getting 0.144 approximately. Okay, so sometimes you're asked to use a calculator, so it's not a big deal, but you need to make sure that you practice it before you get to it. All right. It's also kind of important that we start talking about the differences between even and odd functions and which trig functions are even and odd. That's going to start to become a bigger deal to us as we go on. So odd functions, well, let me first remind you what an even and odd function are. Even function in Algebra 2, most people use like x squared as an even function. An even function has symmetry to the y-axis. So its definition says, whether you plug in a negative x or you plug in a positive x, they're going to be equal. So whether I plug in a 2 to get a 4 or I plug in a negative 2 to get a 4, 4 equals 4. You get the same thing. Okay, and in trig, the only two even functions are cosine and its reciprocal. So cosine, whether you plug in the opposite of the angle or the positive of the angle, they will be equal. And same with secant. So what I'm saying is the cosine of 30 degrees is equal to the cosine of negative 30 degrees. So you get the same thing, but only because those are even functions. An odd function would be like x cubed, and those are symmetric to the origin, meaning you could do a rotation of 180 degrees or flip it upside down. So whether you plug in a negative x or a positive x does make a difference. So they won't be equal, but they're equal if you multiply one of these by a negative. So that's the definition of an odd function. Now the rest of the trig functions are going to be odd functions, so like sine. These are only equal if you multiply one by a negative. Its reciprocal is equal if you multiply it by its negative. We got tangent is odd, and cotangent is odd. So this will be more important as we move throughout the semester, but it's good for you to go ahead and hear it. So in green here, I've got the odd functions, and in purple, the even functions. And all it really comes down to is the type of symmetry that they have. Okay, so how can we piece some of this stuff that I just talked about into constructing the unit circle? Because you will have to have this memorized. The sooner the better. And if you don't memorize it, it makes it really hard to be successful in Precal. Okay, so remember there was 5 values we talked about on the other page. Sometimes we went from 0, and then a little bit bigger than that was 1/2, and a little bit bigger than that was square root of 2 over 2. Bigger than that was square root of 3 over 2. And then the biggest one was 1. So these are really the only 5 values that are going to show up on the unit circle, except for some of them are negative, of course. Well, let's go ahead and fill in the angles, and then we'll come back and do the points. So starting on standard position, this would be 0 degrees, and these big jumps are 30 degrees in a jump, and the small jumps are only 15. So 15, add 15 more, add 30 more. Okay, and I know that it's 90 degrees because that makes a right angle, so that makes sense. So let's go ahead and keep going here. Add 30 because a big jump, 15 for a small jump, 15 for a small jump, 30 for a big jump. And then, of course, as we get closer, we should know that this ends up being 360 because that's all the way around. 360 is coterminal to 0. They land in the same spot. Okay, this blank is for radians because you also need to be able to deal with radians. So this is 0 radians. Actually, I'll do this in a different color. I'll do radians in green. 0 radians all the way around is 2 pi radians. So halfway around would be 1 pi. And then here's how I deal with these. You'll get familiar with them where you don't have to slow down quite as much. But if this is 1 pi, or 180 degrees, I could divide this into 6 equal pieces. So this would be like the first piece, the second, third, fourth, fifth, and sixth. And then you can just count that out, and you're going to get a ton of the radian measures you need to know. So like here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. Now, the only thing different in counting is we want to reduce. So this one reduces to 1 pi, this reduces to 2 pi over 3, this reduces to pi over 2, and this reduces to pi over 3. Okay? But then you're not just limited to quadrants 1 and 2. You can keep going. So that same distance I added for 1 pi over 6, I can keep going. So if this was 6 pi over 6, this would be 7 pi over 6, 8 pi over 6, I'm reducing, 9 pi over 6, reduced, 10 pi over 6, 11 pi over 6, and then 12 pi over 6 reduces to 2 pi, which I know. So notice I didn't hit every radian, but it got most of them. So just thinking about how big 1 pi over 6 is, and then adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just reducing where you can. So the only ones we're missing are these in here. So now, just the same way we divided up pi, let's divide up pi instead of 6 into fourths. So like, here's a fourth of the pi, here's a fourth of the pi radians, this is a fourth of the pi radians, and this is a fourth of the pi radians. So I'm going to count. If I go that distance, here's where 1 pi over 4 is. Add that distance again, gets me 2 pi over 4, which reduces and confirms what I already know. Add it again, 3 pi over 4. Add it again, reduces to pi, which I already know. Add again, 5 pi over 4, 6 pi over 4, reduced, 7 pi over 4, 8 pi over 4, reduced. So you get a little bit of overlap and confirms that you're doing it in the correct way. So when it comes to unit circle questions, step 1 is always finding the right spot. So sometimes it's going to say a degree, sometimes it's going to say an angle, and so you've got to be able to find these locations. So you won't have to memorize what the sine of 10 degrees is. That's not a thing on here. But you absolutely will have to memorize the cosine of 30 degrees and the sine of 30 degrees. So our points around here, these are kind of the second thing, the part that makes this useful to us. And all the way back at the start of our notes, remember I said sine is like the y value on the unit circle and cosine is like the x value. Cosine is x, sine is y. Now that's only true when we're talking about the unit circle, when the radius is 1. But for each of these points I can list off, I'm going to be able to tell you the sine and the cosine of every one of those. Well, remember this is a unit circle, so if I take my length and I go directly to the right, that would be 1, 0. If I went directly up, directly to the left, directly down, and I've got those. Okay, and now let's use, I'll go back to purple here. So for this one, take this point that you're trying to find and imagine it going to the x-axis. That way you can see this right triangle here. Well, think about the two lengths that you have. So one's the biggest length, but just short of that is square root of 3 over 2. So the next biggest length is square root of 3 over 2. Okay, and then for the y lengths, of course 0 is the smallest, but then the next smallest y length is 1/2, and that's the next smallest y length. So that point is at square root of 3 over 2, 1/2. Do the same thing here. This would be the middle x length, middle y length, and the middle lengths are square root of 2 over 2. Okay, take this point you want to find next, draw it to the x-axis, and now it's the small x length, 1/2, big y length, square root of 3 over 2. Okay, and then you can keep going, but what you're going to notice is that quadrant 1, this is the most important one by far. Quadrant 1 is the most important because this reference triangle and this reference triangle, you need to see that they have the same x length, same y length. The only difference is this x length is going to the right and this one's going to the left. So same x length, same y length, it's just that it's going to the left. So now this reference triangle and this reference triangle, you can see they have the same x length, same y length. So square root of 2 over 2, square root of 2 over 2. Only difference is it's going to the left, so make x negative. Okay, small x to the left, big Y up. Okay, and then it follows. This guy is similar to this guy. Same X length, same Y length, but is going left and down. Same X length, same Y length, but it's going left and down. So in this quadrant, it's the same points, but we would have to make sure that X and Y are both negative. Okay, so X is 1/2, this is 1/2. If this is going up square root of 3, this one's going down square root of 3 over 2. Sorry, this one was going up square root of 3 over 2, this one's going down square root of 3 over 2. This length is equal to this length, just different direction. Okay, so it's going right, square root of 2 over 2. So what this one's doing, instead of going up this much, it's going down that much. Right, this, up 1/2, now it's going down 1/2. Okay, so there's quite a bit of repetition there. And I'm going to highlight some of this for you to see. A lot of times when you see pictures of unit circles, they'll like color this one, and then they'll make these the same color. Since they had that same little reference triangle, they have the same point. You just have to think about which quadrant you're in to make the right ones positive or negative. And then oftentimes people like to color these the same. And these the same. Okay, so you should see the pattern there and how that works. Alright, so most of the time you need to use the unit circle. You don't have to construct the whole thing. Usually you just need 1 or 2 pieces of information on it per question. So this is important that you practice it, and I'm going to I cannot stress the importance of unit circle enough. The majority of what we do this semester revolves around the unit circle, and even if you do learn new topics well and you do well with them, if you're making mistakes on the unit circle, it's still going to hold you back a bit. Okay, so here's how it's usually going to be presented to you. You're going to have a question like, what is the cosine of 45 degrees? So in your head, you need to be thinking about, okay, well, where is 45? 45 is about right here. Notice right here. And the point there, so step 1 is locating the right point. Step 2 is I have to know the unit circle well enough to know the point is square root of 2 over 2 and square root of 2 over 2. This. Finally, I have to know that in the unit circle, cosine gives me the x values, or comes from the x values. So the answer to this question is square root of 2 over 2. Now, you can type that in your calculator and it's going to give you a decimal, but no one's interested to see if you can type that one in the calculator, because 45 is an angle that we memorize on the unit circle. That's one that you should be able to do without. Okay, so we could also ask you, what is the sine of 7 pi over 6? And so mentally, you should be thinking about, okay, 7 pi over 6 lands about right here. That point would be left square root of 3 over 2 and down 1/2. But since it's the y, since it's sine, I want the y value, so the answer is negative 1/2. Okay? So you can overcomplicate it more than that, but that's about how direct you need to be. You got to find the location, step 1. You've got to have the point memorized there, step 2. And then if it's sine and cosine, take the x if you want cosine, take the y if you want sine. Okay, but you can also do something like tangent of 135. And then you can go to 135, you can think about its point. And you might say, well, wait, I know this is cosine and I know this is sine. How does that help me get tangent? These points only give me sines and cosines. Well, remember from this quotient identity, with tangent you could always just take its sine value and divide by its cosine value. So I could take its sine value and divide by its cosine value. And then you have to be able to divide fractions. Most people change it to multiplying by the reciprocal. And you can multiply across the top, you can multiply across the bottom. These reduce, you end up with negative 1. Which makes sense. Anytime you divide something by itself, you get 1. But if one's positive and one's negative, you get negative 1. So even though the tangent values aren't listed on here, the fact that the sine and cosine are, we can always divide them to get the tangent values. So that information is still available, it's just a few more steps away. And so I'll leave you with one more example. These reciprocal functions. I could be asked, what is the secant of uh, 11 pi over 6? So those first few steps are still going to be the same. You're going to say, okay, I know where 11 pi over 6 is. Step 1. Step 2, I know the point at 11 pi over 6. Looking at this, and I'm just kind of freehanding it like I would if I was working this question without the unit circle in front of me. And I would say, okay, so here's cosine answer, here's sine answer. Well, secant's the reciprocal of cosine. So if cosine would be square root of 3 over 2, secant is going to be 2 over the square root of 3. And then you're almost done, except again, remember we don't like to leave square roots in our denominator. So you would have to multiply the top and the bottom by the square root of 3. And then you've got your answer. Now, even though this isn't all of the angles, it's quite a few angles, and from these few examples, you can see that you can answer sine, cosine, tangent, secant, cosecant, or cotangent of any one of these based off of memorizing this unit circle, knowing a couple of reciprocal identities, and being able to rationalize denominators. So that's really the point of this section and what we need to start practicing, because the sooner you master this part, the easier the rest of the semester gets by far. All right, so I think that's enough to get you going. As always, please, you're encouraged to go back and rewatch certain parts of this video. Watch them 2 or 3 times if you need to, and then move on to the practice questions to see how you do.